So now that we've worked through limits, we're going to look at derivatives. And of course, this is from Professor Leonard on YouTube. His Calc 1 lecture in 2.2, Techniques of Differentiation is what this is called. The general formula for derivatives allows us to work with more complex polynomial or strings of addition and subtraction in such a way that we can find the derivative much faster. And as you can see, I have the notation of d divided by d of x, and that's finding the derivative with relation to x. And the function we're going to say is x raised to any power. And as you can see, what we're doing is taking n, which is that power, we're bringing it in front, so as a whole, so we're bringing that down and multiplying it by x to that nth power minus 1. So let's work through an example. And I have one here that we're trying to find the derivative of x for this function, 5x to the fourth. So what it says that we can do is we can bring down, let's write the 5 here. So we have 5, and we can bring that 4 down, multiplied by also x to the fourth minus 1. So this is going to give us 5 times 4, which is 20. And x to the fourth minus 1, which is 3. Now, one of the rules that we're applying here is such that we can bring the 5 out in front of our derivative function. So that's actually how we're doing this. I showed you a very quick and easy way. It works every time. This is essentially what we end up doing in the end. So to write this long form, we would first say that it is 5. We bring that all the way to the front, multiplied by the derivative of d x for x to the fourth. And then we would rewrite that as 5. And then we just work with this inside in that general format where we just bring that power down. And then we multiply by x, and it's 4 minus 1. So again, we end up with the same thing, which is 20 x to the third. So let's do one more example where we actually are working with a constant multiplied by a function here, and we're also going to have this as a fraction. So the general formula, remember, the general formula is not as a fraction. So whatever we have for x, we need to make sure that it is no longer in a fractional form. And we can do that. So we can do that by saying that this would be equal to pi multiplied by x to the negative second power. So we just rewrite that in a form that fits that general format above. So then we can go ahead and we can solve this. So this should actually be written as the derivative of d regarding x as pi over, I'm going to rewrite this as pi multiplied by x to the negative second. Now that's in that general format. So then we can go ahead and work on this to solve it. So it says that we need to bring that nth power down to the front. So we're going to just bring that down, the entire value, which is negative 2, multiplied by pi, multiplied by x to the negative 2 minus 1. So that gives us negative 2 times pi times x to the negative 3. And it's as simple as that. And I'm going to work through a couple of more examples in the next video. Thank you.